we are going to create the 3D model of 5th stage compressor rotor blade of an aero engine. Here you can see this is the 3D model that we are going to create. And we are going to create this 3D model by analyzing this industrial drawing. This is the drawing for your 5th stage compressor rotor blade. Here we have the coordinates and this is the drawing. We are going to analyze each and every portion of the drawing and we are going to create this 3D model. We are going to analyze the industrial drawing of 5th compressor rotor blade. Here, if you see, this is the drawing. This is the compressor rotor blade and here, this is the drawing. It composes of two things. First, this entire body made of aerofoils and this is the root, and also we have this transition area which blends the aerofoil body and the root together. Now, if you consider this aerofoil body, this comprises of 5 sections which makes the body. Section 1, 2, 3, 4 and 5. These 5 sections are composing of aerofoils. You can see this is the aerofoil and this aerofoil is present at these 5 positions. Now from bottom when you see, this is the heights at which the sections are present and this is the aerofoil data. You see, this is the data of the aerofoil. We will analyze what actually the drawing represents. Here if you see, this is the aerofoil body comprising of the 5 aerofoils. Now when you come here, this is the root. This is called dovetail root. You can see it is the dovetail root. This is the geometry of the cross section of the dovetail. If you see here, this is AA section. You can see this is the AA section. This is the view, and when you enlarge this view around this area, it looks something like this. And from the top, when you see, the root dimensions are from center line, this is something like this and this 39. So we are going to break down the solution of this project into 3 parts. First is preparing the aerofoil and then creating the aerofoils, then creating the aerofoil body, and the second part is creating the root, the entire root. The third part is combining them by using this transition radius. Now here if you see, this is the aerofoil data. You can see this is the data, and if you consider this area, this table consists of from here to here, these are the coordinates of the aerofoil and these are the various parameters of the aerofoil: chord, Cmax, leading, trailing, radius and so on. But what actually we are interested in is this coordinates. Here the same table that you see in the drawing has been given, and here the data is arranged properly along with z, x, y and g value. Here you can see, okay, this data is for section 1 and this data is for section 2 and so on. So there are 5 sections, up to 5 sections, all the data has been arranged here. What we have to do with this data, we will see. Now from where this g value we have got? If you see the drawing here, from this base, the first section 1 is at 15, second is at 35. So if you see here, see, first section is at 15, see, first section is at 15 and second section is at 35. So this is how the z value has been arranged. Now we will take these 3 values up to here and copy it. Then we will create a new notepad file. Right click, new, text document and simply name it maybe section 1 1. Press on the enter key and enter again. Now as a new file has opened, just Ctrl plus V so that we can paste the data here. This is the profile data, profile coordinate data, and here as there is as we don't have a coordinate for the y, simply I'll delete this line, and if you come over here, we'll also delete this line because we don't have a data. And you can see, just go for file and save it. Now if you come over here, you can rename this. I'll rename this to section 11 dot SLDCRV. .SLDCRV is the format in which Solidworks will accept these coordinates. Press on the enter key. Yes, I want to change the extension of this file, and you can see. So this is how you will copy all the coordinate data and save it in this format. So if you see here, all the work I have done for you, these files will be attached in this lecture, but I recommend that you do it yourself so that you will have practice. See, this is section 1, concave, convex, concave, section 2, and so on up to section 5 it is there. Let us double click on this and I'll go for notepad. Here you can see the data has been properly placed. In the next lecture, we are going to see how to create section 11 inside Solidworks by using this data.